In order to demonstrate this standard, I'm using the question. Two plates have a space between them, D, and it is charged with a battery to create an electric field across the space. If you were to separate them so that the space equals 3D, would the magnitude be greater with the battery connected or disconnected? And then what would the factor be? Oh, I'm supposed to write the magnitude of the electric field. Okay. So for an electric field, you have the equation E equals V over D, V being the voltage and D being the distance. So with it connected, V stays constant, and then as you separate them, D would change and would increase, making E smaller. So that is with the constant, and then if you disconnect it, then the voltage could go down, but then D could also go down, also making E smaller. So either way, you are getting a decrease in the electric field. And then, so with the battery, you do have a continued charge with it as it is decreasing, so E will actually be, will change less in that case than it will is if the battery is disconnected, because that way you have a greater magnitude. For example, if we were to use example numbers, if you had a voltage of 5 and then separated by distance, so it goes from 1 to 3, but your original distance was 1, you get 5, and now you get, what, 1.3 or something like that. It's 5 divided by 1.67. But if you do 5 over 1 for the original one equals 5, but then the voltage decreases to 4, and the distance is by 3, so then you divide that and you get 1.33. So you actually get a greater change with the battery disconnected than you do with the battery connected in this case, as shown by just a little example here of trying to reason through the problem here. And then so if you want to calculate the value, then you have E, V over D. So you, overall, in the end, while you'd get a greater magnitude, you would get a greater value if the battery was still connected. So in that case, it would be if the battery was connected. And then, so for this number, it's fairly easy. You do E and then V over D. But for the new one, it is 3D here. So to get the value for E, you would just divide by 3 here to move it to the side with the E. So then you'd get E over 3 equals V over D. So you would actually have a factor of 1/3, or technically a factor of 3 for the change.